Dear friends, welcome to the next problem of belt drive, that is problem number 16. The data of the problem is like this. A rope drive uses ropes weighing 1.6 kilogram per meter length. The diameter of the pulley is 3.2 meter and has 12 grooves of 40-degree angle. The coefficient of friction between the ropes and the groove sides is zero point 0.3 and the angle of contact is 165 degree. The permissible tension in the ropes is 870 Newton. Determine the speed of the pulley and the power transmitted. Friends, let us first of all note down the given information. Here, the mass of rope per unit length is given. M is equal to 1.6 kilogram per meter. Diameter of the pulley is given 3.2 meter. Number of grooves on the pulleys are given N is equal to 12. The angle of the groove to alpha is given 40 degree. So alpha is equal to 20 degree. Coefficient of friction between pulley and rope is given zero point 0.3. The angle of lap is given theta is equal to 165 degree. Converting it into radian, that is 165 into pi divided by 180, gives theta is equal to 2.88 radian. The maximum tension the rope carries is given T is equal to 870 Newton. We have to find out the speed of the pulley, that is RPM of pulley N, and power transmitted by the drive P. Friends, we know that the speed of the rope when maximum tension in the rope is given by V is equal to under root of T upon 3M, where T is the maximum tension that rope carries and M is the mass of rope per unit length. Substituting these values, the V will be equal to under root of 870 divided by 3 into 1.6. On calculation, we found the speed of the rope V is equal to 13.46 meter per second. Now, we know that the belt velocity V is given by pi into T diameter of pulley into N RPM of pulley divided by 60. So rearranging the terms, we find that RPM of the pulley N is equal to V into 60 divided by pi into diameter of the pulley D. Substituting the values, we found is equal to 13.46 into 60 divided by pi into 3.2. On calculation, we found the speed of the pulley, that is RPM of pulley, is equal to 80.33 RPM. Now we know that the power transmitted by rope is given by that P is equal to N, that is number of ropes, into T1 minus T2 into V, where T1 is tight side tension and T2 is slack side tension and V is the speed of the rope. Here we need to calculate tension T1 and tension T2. So again we know that the maximum tension induced in the rope T is given by addition of two tensions, that is tight side tension T1 and centrifugal tension Tc. So rearranging the terms, we find T1 is equal to T minus Tc, and we know that the Tc is given is equal to m into v square. So T1 will become, on substitution of values, T1 is equal to T minus mv square, where T is equal to 870 minus m is 1.6 and v is 13.46. So we found T1 is equal to 580.12 Newton. Also, it is known that T1 upon T2, that is ratio of tight side tension to slack side tension, is equal to e raised to mu theta by sine alpha. Substituting the values of these parameters, we found T1 upon T2 is equal to e raised to zero point 0.3 into 2.88 divided by sine 20 degree. And it gives T1 upon T2 is equal to 12.50. Rearranging the terms, we found T2 is equal to T1 upon 12.5, and hence substitution of value of T1, that is 580.12, we found T2 is equal to 46.41 Newton. So, using relation 1 to calculate the power transmitted by the system, P is equal to N into T1 minus T2 into V. Upon substitution of value, N is equal to 12, T1 is equal to 580.12 minus T2 is equal to 46.41 into speed V is equal to 13.46. We found power transmitted P is equal to 86,204.83 watt. Rewriting it, P is equal to 86.20 kilowatt. So we can conclude that the speed of the pulley is 80.33 rpm and the power transmitted is 86.20 kilowatt. Thank you very much, friends.